Okay, I am continuing with our mod guide and learning videos for mod 25. I'm going to take a look at did I get this activity on page 164. They've given us a null and alternative hypothesis, a sample size, a test statistic, and they're asking us to find the corresponding p-value. So first, just a reminder actually that just like checkpoint questions, the did I get this and learn by doing questions can actually be different student by student. So you may find out that you have a different null and alternative hypothesis here, but the theory is still the same. And actually, what I'm going to say about this is that we're not going to find this corresponding p-value. Having a test statistic and getting the p-value is something that those applets can do in OLI, but it's not something that StatCrunch can do for us. And realistically, this is just a situation in which you wouldn't find yourself. If you have the test statistic, you should have the data that also came with that. So we're not going to worry so much about this. We're just not going to do it. I've looked at the checkpoint questions. I don't see this anywhere in any of the checkpoint questions, so I think you're fine there. I am just going to say a small thing about how it all fits together. So if this is our test statistic, negative 2.43, that means that in the t distribution of x bar values, our particular x bar value, whatever it is, happens to be 2.43 standard deviations, which we know is called standard errors in this application, below the mean because it is negative. And of course, the mean we're assuming is 50 because that's what HO tells us. So they're asking us to find the corresponding p-value here. So also just a reminder, the p-value is the probability that a sample value in this case would be less than or equal to whatever number it is. We don't know. Why less than? Well, because we know it's below the mean. Under the condition that the mean is 50, just like HO tells us that it is. So how these two would fit together, 2.4 standard errors below the mean is quite far. That makes this occurrence really very unusual. So this p-value would come out fairly small. That small value would then lead us to reject our reject our null hypothesis HO, and then we would support our alternate hypothesis HA. So while we're not going to find this p-value, we can still have understanding of what it is from this test statistic. Okay, let's move on. We're going to take a look at the footnote on the hypothesis test grading rubric. So I have that over here on the right for us. And the footnote appears here and here. So it's dealing with hypothesis tests of population means that we're also going to look at in a matched pairs context in our next video. So for right now, we won't worry about that. But so our footnote is coming into play, having to do with our sample size and getting that sampling distribution to be normal. So this criteria is fine. Sample size greater than or equal to 30, you're automatically good to go. That sampling distribution of x bar values is normal. But we know that if that's not true, there's this requirement that the population has a normal distribution. But how on earth would we know that? We can't ever look at the whole population. We cannot figure out the distribution of the whole population. All we have is what's going on in the sample. So that's what our footnote down here is going to talk about. What needs to go on in the sample? So it says quite often we have to work with a small sample size. And remember, that was exactly William Gossett's issue and how he developed, or why he developed the t-distribution to begin with. And we have no way of knowing the distribution of population data. The best we can do is consider the distribution of sample data. And how do we do that? Well, we make a histogram of our sample data, is usually our go-to. As long as the distribution of sample data that we're seeing in our histogram isn't highly skewed, so it doesn't need to be bell-shaped, it doesn't need to be perfectly symmetric, it just needs to be not highly skewed and doesn't contain outliers. We know that a mean and a standard deviation are greatly affected by outliers. So if we see outliers, we also have a problem, but not highly skewed, no outliers, we can go ahead and proceed on the assumption that the distribution of population data will be normal enough. And then that assumption is also often included with our results. So, we might just say we had a small sample, we went ahead and proceeded, but we know that data varies and there might be a problem. Okay, so let's take a look how we're going to assess that here. Remember that this whole issue of the shape of the distribution of our sample is only important when we have a sample size less than 30. So in our first example here, we have a sample size of 100 individuals. Well, with that sample size of 100, it's greater than 30. This distribution of sample data is skewed. It's skewed right, but honestly, we don't care. It doesn't matter. We don't need to assess that distribution because our sample size is big enough to get that normal sampling distribution. So for my learn by doing, I'm going to pick choice number 2. Conditions are met. It is safe to proceed with the t-test. My sample size is big enough. Oops. Well, I already have this done from a previous try at my video, but let's take a look. This one has 15 individuals. My sample size, 15, is less than 30. So we do need to consider the distribution of our data. Though it's not a bell-shaped, though it's not symmetric, it is not highly skewed, and that's good enough. We also do not see any outliers. There's no big breaks in this histogram. There's no data far away from the rest. So in this case, we're proceeding, but with caution. So I would pick this one. Conditions may not be met. We're going to go ahead and conduct the t-test, but include that disclaimer with our results because, of course, we know that sample data varies. If we take another sample, it is possible we would get some skewing or some outliers. So we're just letting everybody know there's a little cause for concern there. Okay, last one. I have got 17 individuals. So our sample size of 17 is less than 30. We do need to consider the distribution of our sample data, and hopefully what's jumping out at you here is these outliers over on the side. We've got the bulk of our data here, then no data in this block, and then these outliers over here. So this one, our conditions are not met. We should not use the t-test, and we cannot proceed with that hypothesis test. Okay, in the next video, we're going to take a look at comparing two populations with matched pairs data.